We're going to talk about some of the issues related to developing applications in the Android environment. Some of this stuff probably should have appeared before last lecture on activities, but I wanted to make sure that you guys had an example to work from for your programming assignment. So I did it in this order, but if you were going back and watching the videos, it would probably make more sense to watch this video first, because it gives a bit more overall background, a little bit more general discussion. So what we're going to do, this particular module is broken up into a bunch of different parts. We'll get through probably 4 of the parts today, and then we'll cover other parts later. I should also mention that on Wednesday, it's very likely that we'll have the quiz at the beginning of class as opposed to the end of class, so just be aware of that for your planning purposes. And the quiz will cover sort of anything we covered from today and last Wednesday. Those will be the most predominant things we're likely to cover. Typically don't go much beyond that. Okay, so let's talk about what we're going to do here is we're going to talk about the steps involved in building an Android application. Now, a lot of you have probably figured this out already, because otherwise you would have a hard time getting the first programming assignment to work. But I'm going to try to dive down in a bit more detail in some cases and talk in more generality about what's going on there, so you'll have a better feeling for what's happening under the hood. We'll see later that Android and Eclipse especially do a lot of things for you behind the scenes, and so it's really useful sometimes to understand how that stuff works, especially if it goes awry, which it occasionally does. And we'll talk more about that too. Okay, so here are the basic steps, and if you want more information about each of these steps, take a look at the URL here. This gives a text description of some of the things that are going on. So the first thing you do, of course, is you create an Android project which contains a bunch of resources. We'll talk more about those in detail, as well as the stuff that's really the fun part, in my mind at least, which is the code, which is the Java code, usually Java code, which is what you actually write. And then that code gets compiled, and if you're using the Eclipse plugin, the Android development tool, ADT plugin, then this compilation process by default will sort of run automatically in the background. You don't really have to do anything. It's a little bit strange at first, because if you're used to running a compiler explicitly, you don't really see the need for having to do that anymore, because it's being done for you in the background. As you make changes, it's automatically compiling stuff. And if things go awry, then little warnings or errors show up in the view of your source code, and you have to go in and fix that. So what happens after all the compilation is done is eventually things get turned into a package, and the package has got an APK file suffix. You typically don't think a whole lot about this if you're just using Eclipse for development and testing, but if you were really going to be installing your applications, you'll think a lot more about this, because that's a big part of the later process. There's some more information on the ADT toolkit, the Android development toolkit, here at the website. You might want to take a look and see more about what it does. It's very powerful, got a lot of cool features in it that work most of the time, especially if you have enough memory. We'll talk about that later. And then if you want to learn more about the APK files, then there's a Wikipedia entry that talks about some of the things that are in there. We'll talk about them later as well. But if you want to learn more about that stuff, there's a whole bunch of interesting things. And you can actually, go ahead and browse around and see what they look like, and it's kind of interesting to play around there. There's also an important phase that takes place when you're going to release your app for real. In the debugging phase, it's simplified a bit for you, but there's this concept of signing an application, which is just a way to try to certify who developed it and provide some kind of trust relationship so that apps can be confident that if something is signed by HTC or it's signed by Samsung, that you know it's from them. It's not from some subversive organization trying to masquerade as whoever is claiming to be the valid authorizer or certifier for those apps. And then finally, there's an installation phase, and this takes place in a number of different ways. It's either going to, if you plug your phone into your PC, it may end up going ahead and downloading the APK file onto your phone and going ahead and launching it, or letting you launch it. So that's one way to go. And to do that, you typically use something called the Dalvik Debug Monitoring Service, the DDMS. Or there's also a way of doing an emulator. And we'll talk a bit more about these things later. Zach gave an overview of this. You can go back and watch a bit more of the details of setting up those emulators. A really good idea, as we'll talk about in a minute, and we've talked about before, is to install the Intel HAX-M virtualization accelerator. It makes things way, way better. So if you have not installed that, then I highly recommend you do it, because otherwise, if you use an emulator, it's painfully, painfully slow. Once again, as we'll see, it pays to have a lot of memory on your machine. So the bottom line here is that Android and Eclipse automate a lot of the steps necessary to build applications. And this is a wonderful thing. If you'd ever built, back in the bad old days of embedded systems, the world was a lot more complicated, and you had to do a lot more of these steps manually. And that's why people typically didn't like to build embedded systems, because it was hard and the tools were somewhat baroque or broke, depending on your point of view. And nowadays, with things like Eclipse and other tools like this, it's much easier to work with. One thing that takes a little bit getting used to, although Eclipse does a pretty good job of hiding you from this until you try to do somewhat more fancy things, is that there's a bunch of files that are declarative in nature, these XML files, to keep track of layouts and strings and other information, and ways of binding various pieces of your program together. And those files are just as important to successful creation of an app as the Java source code that you write. And that's a little bit different from what you might be used to if you haven't done this kind of development before. If you have done this development before, it's old hat. But people who come directly out of a programming environment where you're just writing C++ code or Java code and you compile it all together, etc., there's some extra things taking place. And there's actually a bunch of interesting patterns in that space. And I'll talk a bit about some of those patterns later. There's a book called Small Memory Software that talks about some of the patterns that are being used here. Things like resourced files and packed data and so on that are worth looking into. If you use Eclipse, sort of everything is magically taken care of for you whenever you sort of save your changes. But when things go wrong, or if you're just really curious to know what's happening, then it's worthwhile understanding more of what's happening behind the scenes. And there's lots of resources that will break this all down for you in great degree of detail. So it pays to look under the hood at times. All right, so quick overview of the build process. You probably, hopefully, have all figured this out. If you're sitting there going, wow, I didn't know any of that, then midnight is a very short time away, right, when the first assignment is due. So hopefully you have, I was just reiterating what you already knew. All right, next thing we're going to do is talk about how to use Eclipse to make a simple app using the Android development environment. This app is really easy. It's something that's almost mindless, but it helps us to walk through the various steps involved and kind of look systematically what's going on. So we're going to make it, the project's going to be named Hello Android. We're going to call the application Hello, Android, just to be a little different. We're going to have a package name, which will be course examples Hello Android, which gets a little bit verbose after a while. We could shorten it if we so chose. And then we're going to have an activity, which is going to be called, of all things, Hello Android Activity. Very creative and imaginative name going into that. And we're going to target this for SDKs that are at least the Froyo release or later. Froyo is not at the dawn of time, but it's sort of like the Mesozoic era or something like that. You know, it's like paleontology. It's a long time ago. There are probably still some Froyo phones running out there, but hopefully most of the people have upgraded at least to Gingerbread, which is the one that came after Froyo. Okay, so the first thing you need to do is start Eclipse. And I remember when I taught this class last year, I had a at the time was a pretty cool laptop, but I had a magnetic disk drive, and I had only 2 gigabytes of memory, and it was painfully slow. So one of the things I did was I got something like 8 gigabytes of memory, and I got a solid state drive, and now it's really fast. So if you have the option of getting more memory, you can't have enough memory, you can't have enough fast enough disk in order to be able to use Eclipse. That's one of the reasons why some people choose not to use it, because it's just such a memory hog. But it'll start up, and then the first thing you do is, if you don't already have an existing file to start from, an existing package to start with, which you could over time, of course, build up a library of those, you'll typically want to go ahead and use some of the wizards that are built in to create a new project. So this is real easy. You open up your Android Eclipse environment, and you go over here and you say new Android application project, and this little thing pops up, right? So that's what you see. And this is the new project wizard, and it's going to prompt you for a bunch of stuff. Now, keep in mind that pretty much everything you type into here, you can easily change later. So if for some reason you get it wrong or you're not satisfied with some of your initial choices, it's not hard at all to go back and edit it. It just requires using some other tools. So in our particular case, we're going to go ahead and specify the name of the application and the name of the project. So the application name is hello, Android. The project name is hello Android. We're going to tell it the package name, which really just says where to put a set of nested subfolders or subdirectories into the underneath the source directory, which we'll talk about later, or the source folder. And that's where your code is going to go, your application's code. I'll fix that while I'm in here. And then you go ahead and set up the version information. Now, for most of what we're doing, just get it to work with the version you're using, so you don't have to get real fancy with this. If you were actually building production Android software, this would start to matter a lot, because you would want to make sure that you were compiling your code in such a way that it was possible to take it and run it on the different phones that you were targeting as a vendor. And so then it would start to make a big difference. Now, if you take a look at the textbook, which is the Busy Coder's Guide to Developing Android Applications, you'll see that there's a lot of discussion about different versions and Android support packages and how to try to be clever and using newer features that are backported to older versions and all this kind of stuff. We're not going to worry about that right now, but people who do this for real have to think about this. We have a couple projects here at Vanderbilt in the Institute for Software Integrated Systems where, for whatever crazy reason, they're stuck at Android 2.2, which I think was the Froyo version. And boy, is that painful, because there's an awful lot of really cool features that have been added in the past 3 or 4 years since Froyo was the release du jour. And so they're kind of stuck. Now, there are ways to backport some of the stuff, but it becomes tricky. So whatever you can do, make sure you, if you possibly can, use the later versions, because they're a lot cooler. And once you're done with that, you click Next, and it'll go ahead and then prompt you for some other things. There's some stuff about layouts and so on and so forth, which I've skipped over here for the time being. But eventually they're going to say, what would you like your default activity name to be? And you can get to choose those kinds of things. As I mentioned before, if you get any of this stuff wrong, then depending on what it is, you can go back and change and fix things, and you can make modifications to the code and so on. And there's actually stuff in here called refactor, where if you want to go through and rename things like activity names or files and so on, you can use refactor, and it will go through and update all the dependencies automatically on the various files that are part of your project. So again, if you decide later you don't like what you called stuff, you can refactor it and change the names. But so take your best shot there. For the simple things we're doing, it doesn't matter that much. In a large-scale system, it makes a big difference. Okay, now again, you can configure this information either using these nice happy wizards, which are pretty straightforward to use, if a bit verbose, or if you're feeling really lucky, you can write it by hand using XML. And we'll talk more about that later. So there's a couple different ways you can go. So Eclipse provides you with a bunch of tools that simplify how you create these applications. The main reason for doing this, by the way, is because there's all this metadata that has to be associated with the Java code that you write. And it's all too easy, as we'll see as we get into this a bit more, to make mistakes with this metadata. Because as I think I mentioned earlier, it's in XML, and XML is Lisp with horns, right? So it's got some demonic possession in it. And it has a tendency to do really strange things when you least expect it. You don't have to use this stuff, but I recommend that you consider using it, because if you don't, you'll be, well, unless you really know what you're doing, if you don't do this, it can be somewhat tedious and error-prone to try to debug the generated XML code. But it's possible. It just takes a while. Does anybody here have any preferences, people who've developed with Android a bit? What do you like to do? Are you a wizard? Do you use wizards? Do you like to write the code yourself in XML? What do you do?
XML.
XML.
I think one of the reasons for doing XML is that they use like static layouts on a lot of stuff. So if you do a more dynamic layout in XML, it'll work on different screen sizes, which Android has a lot of. So
yeah, I have to confess, being an Emacs user myself, I use the wizards usually for a little bit, and I get fed up with them, and I start editing the stuff in XML. But occasionally I regret doing that because it gets all munged. Good syntax highlighters are very helpful, being able to track down things like failing to close the parens and stuff like that. So you get a variety of things. I also have to say, and we'll talk about this in a little bit when we talk about the layout management support that comes with Eclipse, that some of the built-in tools for layout management are a little bit crufty. They're not very sophisticated. So again, people who do this stuff for real either use better tools or they do it manually. Okay, the next topic has to do with some things that relate to understanding the various parts of Android projects. So again, I have a bunch of screenshots here. I will also go back and forth and show this in the Package Explorer, which you can see here. Kind of close things so it's a little bit more concise. And we're just going to kind of walk through the various pieces. So some of you may know a lot of this stuff. For others, this may be unfamiliar territory. So I want to make sure everybody has a chance to get exposed to it. All right. So what is a project? A project is basically a container where you store a bunch of stuff. You store code, or compiled code, and you store the resources that the code needs in order to be able to do its job. And as you'll see, there's a bunch of different things that exist commonly in a project by default. Now, these projects serve a couple purposes. As a development aid, they are used to keep track of a bunch of things that you need to build your app and to be able to associate your Java code with the layouts, with resources, strings, other kinds of information, menus, and so on. But they're also used to build up the information that's going to be ultimately converted into a package, an APK file, and then downloaded to a device and used to run the application in a relatively self-contained way. And there's a whole pile of things in here, which we're going to talk about in a second. Some of these things are things you write, and some of the things are things that are generated for you automatically. And sometimes there's a little combination of things. Sometimes you write stuff, and based on what you write, then some things are generated for you automatically. Other times there's just stuff that kind of is generated for you automatically that you don't really write in any normal sense of the word write. Maybe you drag and drop. So that's another way to look at it. Here are just a quick tour through some of the key directories. There are other stuff, but these are the ones you're typically going to run into most. There's the source directory. We'll talk about that in a second. It contains the source code files, typically Java files, but sometimes other kind of files as well. There's the bin directory, or the binary directory. That's where the output of all the build process goes. These are the things that actually are in executable code. Now, keeping in mind that the executable code here is going to be something that runs in the executable code that's interpreted by the bytecode interpreter. So this would be like a DEX file. By the way, it's perfectly possible, I'll talk about this a little bit later, and we'll look at this in more detail. You can reverse engineer binary code. You can take DEX files and turn them into class files and then reverse engineer those back into source code. So as long as somebody has given you an APK file, then you can reverse engineer chunks of that APK file to see what's in it. Now, people sometimes go to heroic lengths to try to make that code really hard to understand. But if they don't, it's often a good way to get a quick and dirty view of how the source code is written and what things it does. We're not probably going to talk a lot about this in this class, but it's worth knowing about those various times when it comes in handy. There's a JNI directory where you can put the native sources that are used. We talked a little bit about this when we talked about the Android architecture, but one of the things that they did in the Android environment was they provide a lot of implementations, especially of performance critical parts of the system or parts where they want to get certain control over stuff. They write that in C or C++, and that's then accessed by the Java code through the Java Native Interface, or JNI. And that way you can give application developers of Android apps a Java-like experience from a programming point of view, but the JNI code is used for efficiency under the hood because it's compiled. And there are pros and cons of doing this, but it's very, very typical. And if you take a look at Android itself, you'll see lots and lots of examples where things reside. Just to give you an example of this, Let's go over here. And we can look in Dalvik. Let's see. Somewhere in here is the code that deals with the zygote. So we talked about zygote before. Let me see if I can find it. There we go. So in here they have stuff that relates to the zygote files, and they have this stuff implemented in JNI. So a lot of that low-level systemz code is written in C and C++ for efficiency, and then you get access to it through other means just to make it more efficient. Gen, as we'll see, contains some generated code. Assets contains things that you would typically use to store data that are called raw asset files. For example, we did a project over the summer where we had to store some database information, so we stuck the database information in the asset folder and just were able to access it from there. Resources, we'll talk a lot about resources. These are things that keep track of layouts and menus and strings and ways of internationalizing things. And you can also have private libraries that are contained there as well. And there's more stuff that we'll talk about. From our point of view, developing applications and services in Android, there are three key things that we care about. There's lots of other things too, but there are three key things we care about. The first, of course, is the Java code. This is the part where it's the most flexible, typically where the most creativity goes in. That's probably where you'd spend the bulk of your time, unless you're a packager, you're a person who packages up things and creates installations. Then there's the XML-based GUI metadata that's used to manage the layouts, and we'll talk a lot more about this later. You'll get a chance to play around with this. This tells you sort of where to put the widgets in the display that you're showing to the user in your activity. So these would include things like buttons and radio groups and edit views and text views and edit text and all these different kinds of things. Once again, you can either write this yourself or you can use the layout editor. We'll talk more about that. And then finally, we have something called the manifest file, which is a really fascinating part of Android. And it's used to keep track of all the things that Android needs to know about your app in order to be able to integrate it into the Android system. And I'll talk more about that stuff in a second. A lot of different pieces there. In terms of actually breaking things down, your application source code is going to live in the source directory. And as you can see here, here's our little simple example from Eclipse where we've got the hierarchy. This is not actually exactly how the code looks, because if you look at the source code, it's a little different. I'll show you that in a second. But basically, here's the source directory. Then there's some subdirectories under there, culminating in the package name, where we have an activity called Hello Android Activity, which has a couple of methods defined in it. What's fun about this is if we go back over here, and we look at, actually go in here, we take source, course, examples, whoops, wrong directory. No, that's the right one. So you poke around in here, and you see it's actually a number of different layers down. That's kind of collapsed together on your behalf by the Eclipse development environment. So you don't have to see all those different layers. They're just basically empty directories just to keep the hierarchy together. Usually Eclipse will rebuild things, but once in a while it gets confused. It especially gets confused if you edit your source code with a different editor than using the one that comes built into Eclipse. I do that a lot. I just am not that fluent with the Eclipse editor. I can use it for simple things, but I really like to work with Emacs, so I would typically find myself going in here and doing the editing there. And when I save this, and then I would pop back over to the environment here, typically what will happen is it'll recognize that something has changed, and it'll go ahead and update it automatically. But sometimes it gets confused. So when that happens, if it happens, then what you probably want to do is come up here and manually clean things out. And that usually fixes it. If everything is still going awry, and I was playing around with some stuff last night preparing for the lecture, and I knew that something was correct, but it kept saying it was an error. So finally I just shut down the whole Eclipse environment and restarted it, and of course it magically started and worked just fine. Which is sort of equivalent to rebooting your Windows machine when everything else fails. Right? That usually fixes most silly problems if you reboot stuff. So just be aware of that. Normally it should build automatically. Of course, you can disable that if you want to build it manually, but it should normally work. But just be aware there will be times when it won't work, and it'll drive you absolutely berserk because you won't know what's going on. So, as usual, cleaning things out and starting over from scratch is occasionally very powerful. The gen directory is kind of interesting. So there's a bunch of things that are generated for you automatically. One of the things that gets generated for you automatically are these resource files, the r.java files. We'll talk more about them on the next slide. There's also some other stuff which we're going to get to a little bit later in the course that has to do with the stubs that are generated automatically by the Android Interface Definition Language, or AIDL compiler. And what's cool about this is you just have to throw the foo.aidl file into your source directory, and then magically the Eclipse environment picks this up and says, aha, this person has an AIDL file that's dependent on all this stuff that I'm doing here. And it will automatically go ahead and generate code for you, and it sticks the generated code over in the gen directory. And you can go look at that code if you want. I would highly recommend not editing it again, because it will change out from underneath you next time you make the change to the AIDL file. But that's a place that are used to keep track of these things. By the way, we're teaching makefiles in CS 251 this semester. And it's kind of funny because it really makes you appreciate two things. First of all, it makes you appreciate people who understand makefiles, because they are very, very complicated. It's relatively straightforward to do really simple things. When you start doing really complicated things, it's next to impossible to figure out unless you're an expert. And it makes you appreciate the kind of automatic build environments people have come to know and love, like Eclipse or Visual Studio, where a lot of that stuff is kind of done for you behind the scenes. And even though it's there, you don't have to really know all those details. Of course, when things go wrong, then you're up the creek. So there are pros and cons to having that control. Don't put stuff in the gen directory. It's not meant to be something that you manipulate yourself. It's something that the tools do for you. The r.java file is something that's typically used to fetch various GUI resources and widgets throughout your code. We'll look at some examples of that shortly. Just be aware that that code is available if you want to go and look at it. It's all here. And when you look at it, you'll be like, what the heck is going on here? Because basically all it really is are ints that are essentially pointers that point off into different parts of your program. And this is a good example of, if you really want to know what's going on behind the scenes, be prepared for some interesting stuff. Mostly you just have to know how to use this, but it is pretty cool to see how it works. We'll look at some examples later. Another folder that's important to know about, especially if you start doing more sophisticated kinds of Android development than we're doing at the moment, but we will get to later, is the resource or res folder. And this contains so-called non-code resources. So this is not Java code. This is described in XML, typically. And it's used to keep track of things like layouts, how it puts the widgets onto the display, menu, different options, images, strings, all kinds of different things. And there are a bunch of different options here. One of the things that has happened over time is that different manufacturers have taken the Android source code, and then they've created a whole bunch of different kinds of form factors for Android. So you've got things with big screens like tablets, you've got different sizes of tablets. You've got things with reasonably big screens like these types of phones, like the HTC One or the Galaxy Nexus. That's what most people think of when they think of an Android phone, probably is something like that. But they also have ones that are smaller. They also have ones that are much bigger, like the Galaxy Note, Galaxy Note 2. And so all those different phones have different screen sizes, different resolutions of the pixel density, and so on. And so if you're trying to build apps that are going to run on all these different phones without change, you have your work cut out for you trying to keep track of all these different screen sizes and densities of the resolution. So to help you with that, Android defines a bunch of different subdirectories in the resource folder that you can use to store images with different resolutions. and then it'll pick amongst those when it's going to decide how to display your application. On Wednesday, we're probably going to talk a bit more about something called fragments, which is a way of handling some parts of this related to dealing with the logic for single screen devices like a phone, like a smartphone, versus multi-screen things that you would get with, or not multi-screen, but bigger screens that you would get with something like a tablet. So we'll talk about that. There's lots more information about how to deal with this. You're most likely to run across this if you start building production Android applications. Once again, you can define your GUI either in XML or by using the GUI layout editor, like this one here, which I use just to whip my application up real quickly. Again, it's a little bit goofy, but it's good enough to get things done quickly for short demos and stuff. The XML files for the layout are stored in a directory called layout. And as you can see here, we just have a single layout because we just have a single screen. In practice, however, there are often lots and lots and lots and lots of these things. So let's take a look over here. Let's go take a look at a browser, for example. This is the ice cream sandwich browser directory for the open source version. And if you go into resource and you look in layout, you can see there's quite a lot of different layouts for different screens that a browser would have. So there's things here, take a look for bookmarks, there's stuff in here for history, there's things in here for title bars and video loading progress and so on and so forth. And this is all giving you different descriptions of how to lay out the widgets for that particular view. So in a real life application, there's often quite a bit of different parts that are being used here. As before, I strongly encourage you to take a look at the Android source code if you have a chance. Download it. It's worth taking a look at. And there's more information about how to use the graphical editor that's available here. There's also some other interesting things that are part of the Android release, and sometimes it's not entirely clear why packages contain some of this information. One of the ones that you'll come across at first and wonder, why is this here, is something called values/strings.xml. And here's an example of the contents of the strings.xml file. We'll look at this when we look at the app code here in a minute. We'll look at a bit more ways in which these things are used. Does anybody know why there's a way of being able to have a file that contains strings accessed by labels or names? What's the motivation for this in Android? Yeah?
Is it so you can cross-reference between like XML named things and Java named things? You can't do global any other way?
Great. Yeah. So one good observation is it's a way of being able to allow more refactored cross-referencing. So you can have Java stuff that refers to things in XML files. We'll come back in a second as to why they do that in the first place, but rather than hard-coding them into the Java files. Another thing you can do is you can cross-reference things from XML files to XML files. So for example, in your layout file, you might have the name of something. You might have like the name of the application, or you might have the name of a string that you would define as part of your layout. And then that itself can refer to something that's defined in the strings.html or strings.xml file. But the bigger question really is, why even do this at all? What's the benefit? Austin?
What happens when you want to put your app in 50 different languages?
Right. So the point there is internationalization, or what is sometimes referred to as I-18N, for people who don't like to say internationalization, because there's 18 letters there. Go figure it out. I guess they didn't want to translate internationalization into different languages, so they just called it I-18N, and everybody just memorized that, right? So internationalization, if you want to sell your app and you want to sell it in the German market, or the Korean market, or the Japanese market, or the Chinese market, and then there's different variations in different dialects or different sub-dialects and so on. This way you can use references in your Java code or your XML code to something that gets replaced by whatever happens to be the corresponding translation of that phrase or that name in the language, the human language that you're working with. So that's the main reason why that's done, to be able to enable that. Cross-referencing also helps too, to try to factor things. It kind of goes back to one of the points we talked about before, one of the patterns we talked about, where you try to avoid duplicating stuff. You want to have it done in one place and then have references to those things. There's a famous joke about computer science that says, no problem is so complex in computer science, it can't be solved with enough levels of indirection. So this is sort of one of those things. You have indirection to stuff. The next topic, one of the more interesting parts of Android, and for my money, one of the things that makes it the most different from other prior smartphone technologies you might happen to run across, is something called the Android manifest.xml file. And this file contains information represented in XML that is used by the Android system in order to actually execute your application once it downloads it and then allows it to be run. And it exists, it's an XML file. There's also a binary version of this thing that's actually part of the package that's released. And that's why if you ever try to reverse engineer a package, the first thing you typically have to do is go find the Android manifest file and then convert that from binary back into a text version so you can actually look and see what's in it, what the various elements are. Android has this cool app component framework, which is glued together by intents. And it has all these different components we talked about, right? So broadcast receivers, content providers, activities, services, and so on. And these different components have to be described in some way, and you have to be able to tell Android what your app is providing or defining or using, so it knows how to plug your app into the other stuff that comes along in the Android framework. Now, some stuff is just sort of fixed and is very fundamental. Other things are subject to be changed and replaced. And that's one of the wonderful things that makes Android so powerful, is its ability to be able to plug and reuse. And we can talk about things like the tasks, activities we talked about before, where you can make an application out of a bunch of other activities that pre-existed, and you use them to build the overall app. Anything that uses the contacts or calendar or email would be a good example of that type of reuse. There's a good article that explains manifests on the Android website. When you install an app from the App Store, the Play Store, there's a piece of logic on your phone called the package manager that's actually responsible for parsing that manifest file and then going and looking up inside of the package to get access to all the things that are referenced in that manifest file. And once those things have been discovered, it stores them away into some internal data structures. And then the package manager and other managers, like the activity manager, access those internal data structures while the system is running to check on various things on your behalf. So for example, for the programming assignment that's due tonight, if you take a look at the way you're recommended to check to see whether or not your phone installation can handle geo-intents, you'll see that you use this package manager query intent activities method, and you pass in the intent you'd like to be able to send out, and it will come back and let you know whether there's anybody who knows how to handle that. If you come back and there's something that's, if there's no activities, you'll get a size back that's 0. You get back basically a list of 0-sized elements. If there is something, then there'll be something in there. And so then you know you can go ahead and start that activity with confidence it'll actually be run in a sensible way. So that's kind of what's happening beneath the hood, or behind the scenes. It's really interesting. If you ever want to make your mind melt, go take a look at the code inside of the package activity manager, or the package manager and the activity manager. It's very, very, very complicated. It's basically parsing the file and looking for all the different things and building these internal data structures and keeping track of what various parts of the code will match different kinds of filters. It's really a fascinating thing to take a look at if you have a lot of time on your hands. There's a bunch of information that's contained in a manifest file. And once again, this is something that is really worthwhile exploring in the source code of Android itself. I'll take a quick look in a second just to give you a peek at this. But here is some of the information that's typically provided in the file. There's typically stuff in there that says the application name and some information about the application, like its required platform version, what its minimum API level is that it's been compiled against. There's typically a list of various components, activities, or services, or content providers, or broadcast receivers that are defined by this app. There are also certain kinds of events that this app may be willing to listen for, or its components may be willing to listen for, in case they get broadcast. This app and some of its components might be able to handle those types of events. You can also request various kinds of security permissions. You can also indicate whether or not your app can be debugged or not. Typically, when you're building things for internal use, say pre-release use, you want all this stuff to be debugged so people can attach the debugger and the emulator and poke around and set breakpoints and so on. But oftentimes when you go ahead and ship the actual release version of the code, you want to strip out all of that information, either to make your code a little bit smaller and faster, or because you don't want anybody to figure out how to re-engineer it or reverse engineer it. Different reasons for different purposes. Lots of good stuff in this file that talks more about what goes into a manifest file. Just for kicks, let's go take a look at a manifest file or two, just to see some examples of what they do. So, pop up a level. Here's the manifest file for the browser. And as you can see, it's pretty gigantic, a lot of stuff. And it's not even the most complicated one by any means. So you can see here's the content provider that's provided by the browser. The browser app in Android historically has its own content provider where it stores things like bookmarks, or it stores things like the history of searches and so on. It uses these to provide suggestions. If you type stuff in, it'll give you suggestions based on things you've already looked at before. So it stores those as a content provider in an SQLite database. There's an activity. The main activity is browser activity. And so when you start up a browser, that's what you're going to see. And you can see here that there are various types of events that it knows how to deal with. It can handle voice search results. It has a view, so if you want to view a web page, it knows how to view those kinds of things. And lots and lots and lots of different kinds of intents can be handled by the browser. Web searches, other kinds of things. And again, if you poke around in this stuff, you'll find lots of other examples. And these are other application activities or services and so on that are provided by the browser. And they're all defined here. So there's one convenient place you can look to find out what they do. And that's not just for you, for your purposes, but even more importantly, it's for the Android package managers and activity managers purposes. So as you load all these different apps onto your phone, it can interrogate their manifest files and then populate those internal data structures. So it knows what events, what intents are capable of being handled by different kinds of handlers, activities, services, and so on. So this is a really cool example of late binding and loose coupling, where you really don't know until you run your intent who on the phone is going to handle it, unless you cheat and you check to see whether or not the package manager knows how to handle it. But that'll just tell you who does know how to handle it. So it gives you a lot of flexibility in adding things to the system and making it more dynamic. So projects basically act as containers to store a bunch of stuff, code, and other resources that they need to run. The tools that Android provides in the software development kit expect all this stuff to be laid out in a very well-defined manner via a specific set of structures, data structures, relationships. So the tools that you get with Eclipse help to make sure that that happens. Or command line tools you can also run if you like the command line environment. You're welcome to do it yourself, but if you get out of sync, really strange things happen. I've never pushed it to the limit, so I don't know how robust Android is if you start feeding it just garbage manifest files, whether it just goes berserk or what it does, but it probably is not a good thing. We primarily here have focused on Android projects, which is what we typically use to build the applications, the activities, and so on that we're going to be doing. Be aware that there's a couple of other kinds of projects as well. There are test projects where you can set things up in order to be able to run test applications, test unit testing and so on, integration testing to see whether things behave the way you expect them to do. Just like you would for anything else, it's important to write test cases for all your smartphone apps. People are no less annoyed if they don't work than they are in any other kind of environment. And then there's also projects called library projects, which are typically things that are used to share code between different applications. So you can make a library project and put some reusable stuff into it and then have multiple different applications share that. So it might not be an application itself, but it's basically something that provides resources that can be used by other applications. The Busy Coder's Guide to Android Development talks about these kinds of projects as well. Okay, any questions about that? Hopefully that's mostly recap, but the good news is you ought to be able to now look a little bit more into the code that's there in or the various tabs and directories and so on that are in your Eclipse environment to get a better sense of what's happening under the hood. The last piece of the puzzle we're going to talk about today is really how to use Eclipse to create a very simple application. And this will take some of the things we just talked about and go a little bit deeper into the details of how they work under the hood. So the first thing we're going to do is we're going to define some of the layouts, some of the resources that we have, and so on. There's lots of things you can do this way. We're just going to focus on a couple of them. So the first thing we're going to do is lay out the user interface. Now, there's a lot involved in doing this for real. We're just doing a very simple one, so we're not getting too carried away with how it's going to look. It's very simple, and it's just going to look like that, which isn't even very interesting at some level. But what you basically can do, either with the tool or without the tool, is you can go ahead and write the code that explains how to do this. And there's a bunch of different tags here in XML that say how to align this particular widget or this particular layout relative to other things. As you can see here, all we have is a text view. You can also see something we'll talk about in just a minute about how we've referred to this using the abstraction and the indirection of being able to refer to this by the label. So rather than a hard coding hello Android, instead we say go look up in the string resource file a label called hello Android, and then whatever that happens to be, use that as the particular text we want to display in this text view. So that gives you this level of indirection that we had talked about before. The way that you would actually access this stuff, and we'll talk more about this in a second, but if you were writing your application, depending on what you were doing, then you could refer to this particular chunk of code via the R resources. So in this particular case, we're going to take this guy, and we're going to be able to make that guy the content view by simply saying r.layout.main. And that's the thing that points to the main content view, which would get us something that looks like that. We'll see later that you can poke around and get access to other things in the R resources, and we'll see that in just a second. Next thing we'll talk about is getting access to the string resources. Now again, I didn't really mandate this as a requirement. Maybe I did. I think it might be actually mandated as a requirement for the programming assignment. But regardless, it's not hard to do. First thing you have to understand is there's a bunch of different kinds of strings you can have. You can have a string, you can have an array of strings, some other things as well. You can also, because it's just text, you can also encode various kinds of HTML formatting into the text. So you can boldface it, you can italicize it, you can do pretty much anything you would normally do with HTML or XML-like encoding in order to make that work. A limited subset of those things. 3 things, in fact. Okay. Each string is then actually stored in this particular file. So as you can see here, this is how you access from another file. So here's our result resource layout activity hello Android file, the XML file. And there it references this file here, the hello Android file. And then you could access that by saying r.string hello Android. Okay, so that's how you get access to strings. The bottom line here is, as a general rule of thumb, unless you're just doing quick and dirty debugging and it's too frustrating to keep track of all this indirection, use the strings file under the values folder, subfolder in the resources directory rather than the hard coding the strings into your application. It's okay for simple things, but as a general rule, try to use this. The next thing is how do you actually get all these resources? And so this is something that's handled by a resources compiler, which is called AAPT. I'm not exactly sure what AAPT stands for. Does anybody know what AAPT stands for? When I looked it up, it just said AAPT is the resources compiler. So maybe in some like strange language, it says resources or something. So basically what happens here is that at the appropriate time, it takes the XML layout files and the Android manifest file, runs them through that particular tool, and then it generates out these compiled XML files, which you access via the r.java package directive, and you can import that, and you can access those things. Here's what it looks like if you take a look at what the actual class looks like. You can see here we've got, for example, r.layout.activity hello Android, which refers us to this pointer-like thing. And here's r.string.hello Android, and so on. So you can access these things in various ways. If you take a look at this link here, smallmemory.com, there's an interesting book written by a couple of well-known pattern experts, Charles Weir and James Noble, and they talk about a bunch of patterns people use if they're trying to develop software that runs in resource-constrained environments. And a number of the chapters in the book are available online, not the whole thing, but a bunch of the different pieces of them. I'll probably talk about some of these patterns later because they're really important to understand how some parts of Android works. But one of the patterns that they talk about is something called resource files. Let's see if I can looked it up. Resource files. There we go. So the resource files pattern, they talk about a bunch of different patterns that Android uses in order to be able to access the information in an indirect-like way. So if you're into knowing the patterns that go behind this, it might be something you want to take a look at. And again, you can access these things as we just saw. Finally, get around to the point where you can actually write some Java code after you set up all this infrastructure, or the Android Eclipse environment sets it up for you. So typically come along and you import various things, and then you can go ahead and access the parts of your application and write the code doing things in your onCreate hook method. In this particular case, we're going to do something very simple. When onCreate is called, we're going to make a new text view. We're going to go ahead and set the text in the text view to be equal to the values that are in the hello Android string. It's part of our resources file. And then we make that the content view, and then that pops up the display that we see here. And typically, as you change screens, you're going to be changing the activities that go along with them and the resources that are associated in the layout files and the string files and so on and so forth. And then here's a little snippet of this showing you what things look like underneath the hood in the manifest file, where we have the name of this, and it tells what intents it knows how to handle when you launch that activity. So here's an interesting picture that you can take a look at. There's a nice website that goes into a lot of detail. This shows how all the different pieces we've talked about so far all play together. So you take all those resource files, which seems to be misspelled. That's funny. I don't know how long that picture's been on the Android website, but it says resources, not resources. And you take all those XML files and you run it through the AAPT compiler, and that generates the r.java implementation. You take that plus the source code plus any Java interfaces and stubs and so on that were generated automatically by other files like the AIDL compiler. And all of that stuff gets run automatically through a Java compiler, which then turns into class files. And then there's a tool called DEX, which is the tool that reads Java class files, converts those into DEX files, which is actually the binary format that's run on the Android phones themselves. And then the DEX files, the executable bytecode DEX files, are combined with the compiled resources files in order to, and then integrated with this thing called the APK builder. And that creates an Android package. And then that goes to something called the jar signer, which gives you a signed APK. And then that thing can finally be released. You can install it and so on. And there's a lot of nice description that talks about how all those different steps work here at the website. OK, any questions about any of those things? So at this point, you've seen the whole process from start to finish. You've hopefully done most of these steps already. I encourage you to get your stuff done. I'll start sending back commented versions probably by tomorrow, knock on wood. If I'm lucky, I should get everybody's first round of submissions done by Wednesday. And you'll see when I send you the email back with the comments, you have a week from the time when you get the comments back to make the changes and then send them back to the graders, the TAs, for their final inspection. If there's any questions, send me email. Take a look at the website for office hours if you run into problems, or send email, and we'll endeavor to get them fixed.